Namaskar. I am Meha Saxena, Assistant Professor, IIS deemed to be University Jaipur, and today we will discuss about the chi-square test. In this video, we will be talking about the introduction to the chi-square test, which includes the difference between the parametric and the non-parametric tests, some important terms related to chi-square test. Then we will discuss about the chi-square test and its applications. Introducing to the chi-square test, first we need to know about the difference between the parametric and the non-parametric tests. A parametric test is a test which uses quantitative data, that is, data which is parametric in nature, which means that it is possible for us to find out the mean and the standard deviations for such kind of data. For example, if we are working upon the heights of people, we can easily find out the mean height by adding and dividing by the total number, and we can also find out the standard deviation. Similarly, we can work on the production of crops in the same way. One important thing about parametric tests is that the population information is available in such cases and the data is based on normal distribution. When we talk about the non-parametric tests, we can say that the data in this case is qualitative or it is subjective, or we can say that the study is conceptual in nature. The data is called to be non-parametric as the mean and standard deviations cannot be found. For example, if we are working on the consumer preference, we cannot find out the average preference. The population information may not be available in such cases, and the data is not normally distributed, though it may be distributed binomially or in Poisson distribution, but that is not a must. Now talking about the different parametric tests available for hypothesis testing, we can say that if we are having a parametric data, we can either go for a Z test or a T test in case we have two different samples given to us based on the different sample sizes. If we have more than two samples, we can go for ANOVA. For non-parametric tests, we can have tests like chi-square test, Mann-Whitney's U test, Wilcoxon sign test, etc. In this video, our major concentration is on chi-square test. Now, before we proceed to chi-square test, we need to understand some important terms related to chi-square test. The first of them is the degree of freedom. Degree of freedom, which is denoted by nu, is a very important term with respect to chi-square test. It tells us about the extent of freedom or independence enjoyed by a given set of observed frequencies. That means, in a particular data set, how many observations are actually free or independent to take up any value without being dependent on any other value in the data set. To understand this better, let us take up an example of a kg of apples. Supposedly, we are buying 1 kg of apples and we get 5 apples in all. We wish to know the different weights of the apples in, in that 1 kg. Now, we say that if the first apple is 200 grams, that does not affect the value of the second, third, fourth, or the fifth apple right now. Similarly, if we talk about the weight of the second apple, this also is independent of the other values. That means if we are knowing the value of 4 apples, we can find out the value of the fifth apple by subtracting from 1 kg, which means that the value of the fifth apple is dependent upon the value of the other 4 apples. So we can say that the first 4 apples are free or independent to take up any value, but the value of the fifth apple is dependent upon the other four. That is why the degree of freedom in this case will be 4. Similarly, if you want to find out the degree of freedom for any data set, the formula for the same is n minus 1. Talking about the next important term we can say is a contingency table. A contingency table is nothing but a two-dimensional table in which you can take up your own data or the frequencies. You can store the frequencies in the form of rows and columns. So, when a table is prepared by enumeration of qualitative data by entering the actual frequencies, by distributing the values according to different states of nature in a two-dimensional matrix, it is called as contingency table. A contingency table has got rows and columns, where the number of rows are denoted by R and the number of columns are denoted by C. The order of the table is called as m by n, where m is the number of rows which is equal to R and n is equal to C, which is the number of columns. Now, the degree of freedom for contingency table is not calculated directly but has a different formula. Let us see why. Supposedly, if we have a 2 by 2 matrix where the first value is 25 and we have been given the row totals as 50 and 50 while the column totals are 70 and 30. Now, talking about the second value is dependent upon the first value and the row total. So the first value is 25 and the row total is 50. So automatically the second value is equal to 25. Similarly, third value is dependent upon the column total and the first value. So for a first column, if the total is 70, but the first element is 25, automatically the third element has to be 45. Similarly, the last element is equal to 5. That means the other three values are dependent upon the first value. Hence, the degree of freedom in this case is 1. Similarly, for a 2 by 4 matrix, you will see that the degree of freedom will be equal to 3. So how to calculate the degree of freedom for contingency tables? Well, the formula is very simple. The nu is equal to r minus 1 into c minus 1, where r is again the same number of rows and c is the number of columns. Now, talking about the chi-square tests. Chi-square test is basically a non-parametric test developed by Carl Pearson in 1900. It is not based on any assumptions or distribution of variables, though we can say that it follows a chi-square distribution. Now, chi-square distribution has its own unique value that it is a right-tailed test. It will never be a left-tailed or a two-tailed test. That means the rejection region will always lie on the right-hand side. Chi-square test is basically used to find out a significant difference between the expected and the observed frequencies or values that is the values what should be there actually theoretically and what is actually observed. So it finds out the significant difference between the two. It can be used to see if two or more populations have significant variations non-parametrically or not. The next is the different types of chi-square test or the application of chi-square test. Chi-square test can be used in three ways. The first is a chi-square test for goodness of fit. This test is basically used to check whether the observed data can fit into any of the expected frequency distributions or the probability distributions like binomial distribution, Poisson distribution, normal distribution or not. The degree of freedom in this case is generally taken up as n minus 1. The second test is called as the test of homogeneity. It is used to test whether the occurrence of events are distributed evenly or distributed over a period of time. That is, the same frequency is occurring every hour or every day or every month, whatever the criteria is. In this case, the degree of freedom is equal to again n minus 1, but here n is the number of time units. Let's say, for example, the number of days, number of hours, etc. And the last is the chi-square test of independence. The chi-square test of independence is used to test if two or more attributes are associated or affected by each other or not. It is generally expressed in terms of contingency table, and hence the formula for degree of freedom is r minus 1 into c minus 1. Thank you.